So today we are going to start with DUIS, that is differentiation under integral sign. Okay. The short form is DUIS, which is differentiation under integral sign. So what do you think this will be? The name suggests you anything? Differentiation under integral sign. So what will happen here? Just a wild guess that you can take. Think it quickly, otherwise I'll move on and I'll explain. Differentiation under yeah.
Maybe negative areas will cancel out.
But still that will be only area means integration. But here they are saying differentiation under integral sign. So what do you think it suggests?
Give us we will obtain functions. Right.
See, basically, take out the literal meaning of this statement, whatever I have written. The four words which are there, differentiation under integral sign. So what is the literal meaning, English meaning of this four words? What do you mean? What do you think it is?
We will do integration of differential equations or something.
Yes. Inside the integration sign, there will be differentiation. Is it okay? We are going to do derivation or differentiation inside the integration. So for that, first of all, you have to understand if this is happening, that means the variable which is to be integrated, that will be one, and the variable which has to be differentiated, that will be another. If they were same, then they would have cancelled each other and would have got constant, no? Because what is the relation between differentiation and integration?
Opposite of each other.
They are opposite of inverses of each other, so they would have cancelled. So if it was deba by deba or d by dx of the function into dx, then that dx would have cancelled, integration and d would have cancelled like this. Suppose it was like this, d by dx of f of x, and then integration again with respect to x. If this was the thing, then this dx would have got cancelled. This dx integration would have got cancelled, and your answer would have been just f of x. Getting it?
Yes.
This is the basic thing about differentiation and integration sign. That's why this variable and this variable should be different. Are you getting it?
Yes, ma'am.
That's why we are going to look at integrations of this type. F of x comma alpha dx. This is the basic integration that we will find. Find the integration which finally depends on alpha of integration f of x comma alpha dx, where alpha is said to be a variable parameter and x is the integration variable. Is it okay? You understand why I told you this? Because if the differentiation you want to do, if the differentiation is also to be done with respect to the same variable, dx will get cancelled, dn integration will get cancelled, and answer will be f of x. You don't have to do anything. But that's why it won't be same variable, it will be different. So alpha is your parameter with respect to which you have to do differentiation. So di by d alpha, and that will be how it will be written, that are the rules. So that is differentiation should be done with respect to alpha of f of x comma alpha, and then whatever is the answer, it's integration. And if I want the answer of this integration, I will have to again solve this differential equation and get back the answer. Is this okay? Are you getting what we are going to do and what is the need? There are certain functions or there are certain scenarios where you get the integration in terms of x and alpha. Rather than going into double integration, we will try to see whether I can get the value of this integration by differentiating first and then integrating again, so that whatever is the area covered by this curve will be on. Where you come across this, you will come across this in terms of Laplace transform and Fourier transform, which you are going to do in M3. So that time, your alpha is a parameter which will be the answer of final integration. Laplace transform transforms the function integration in terms of a parameter alpha. And then when you are not able to solve that integration, you are going to take a differential equation. Corresponding to this, there is a differential equation which can be solved by the techniques in M3. Differentiation of solution of differential equation of higher order. So that we are going to do in M3. Laplace transform, Fourier transform is also done in M3, and that time will come across such type of functions. Integration f of x comma alpha, where x is the variable with respect to which you have to do integration, and alpha is the parameter, which is the final answer which is appearing in your integration. Do you understand the difference? समझ में आ रहा है क्या कर रहे हैं और क्यों कर रहे हैं?
Yes, ma'am.
Everyone.
Yes, ma'am.
Solving is very easy, but why we are doing that is one very important point, and that's why I'm telling you that the name differentiation under integral suggests that you have to do differentiation under integration. But if the variables are same, there is nothing to be done. Directly you get the answer as f of x. Hence, differentiation is with respect to some other variable, and integration is with respect to some other variable. That variable with respect to which I am differentiating is called as parameter, and the variable with respect to which I am doing integration is called as integration variable. Is it okay? And then, since the integration is becoming difficult, first I am differentiate, get this answer, and then solve the differential equation to obtain the relation between I alpha, which is the integration of this particular function. Clear? Where we are going to come across this Laplace transform and Fourier transform, we are going to come across such type of integrations. So why we are doing it? Because Laplace transform and Fourier transform will be useful to solve different type of differential equations for data which is not in mathematical form. We are going to convert it to that form, and then we are going to solve it by this as well. Okay? Clear up till this?
Yes, ma'am.
Now let us go to see what are the rules. So there are two rules basically. First is called as DUIS root 1, and second one is DUIS root 2. Before going ahead, tell me whether this will be d by d alpha or delta by delta alpha. How many variables are present here? This function.
Two variables.
Yes, this function is depending on two variables. So whenever the function is depending on more than one variable, we don't have ordinary derivative, we have
Yeah,
partial.
exactly.
Okay, we have partial derivative. I didn't write it initially because I wanted to tell you we are doing differentiation. So differentiation is d by d variable. But now there are two terms, two variables. That's why it won't be ordinary derivative, it will be partial. Is it okay?
Yes, ma'am.
Yes, ma'am.
Now, what is the rule? This is not just indefinite integration. Plus C is not there. That means there will be limits given. There will be limits given. Okay. So, what are those limits? Whether they are constant or they are depending on this parameter alpha. These are the two rules. Rule 1 is for A and B constant. If A, B are constant. And rule 2 is for US rule 2. If A and B are depending on alpha. If A and B are depending on alpha. Is it okay? Clear? So what we are going to do?
Yeah.
We are going to do differentiation under integration, in which there are two rules. Why there are two rules? Because if these two are constant, then one thing will happen. And if these two are depending on alpha, then I have to take care of these limits also. When I am differentiating, I have to think about differentiation of these limits also, because they appear inside. So that's why I want to. Afterwards, when I explain both the rules, I tell you what is the relation between the rules. Or you only will tell me. If you understand, once you understand the rules, you only will tell me what is the relation between them. Is this okay?
Yes, ma'am.
Okay. So now let's go ahead and actually write down the rules. The proof we are not going to go into depth of it. While writing only you understand why we are writing it in that. Okay. So we write down the heading as differentiation under integral sign. Write down heading as differentiation under integral sign. Okay. Differentiation under integral sign means to solve integration of the type I I alpha equal to integration a to b f of x comma alpha dx means to solve integration of the type integration of the type I alpha is equal to integration a to b f of x comma alpha dx where x is the integration variable and alpha is parameter variable. We first differentiate I with respect to alpha. That is di alpha by d alpha. Is this okay? Why I am writing d here? Why I am writing d over here? So there is only one variable. So no diagonal. Okay? Di alpha by d alpha. And then integrate the octane differential equation. Integrate the octane differential equation to find the final integration. Integrate the octane differential equation to obtain integration I alpha. Did you understand what is the meaning or whatever we have written? Is it clear what we have written?
Yes, ma'am.
Okay. We are going to integrate. First, we are going to differentiate it, and then we are going to integrate it because ultimately I want the answer of this integration. If I just write down the derivative, I get what is the change in I alpha with respect to alpha. I won't get the answer of this integration. That's why I have to solve that differential equation to get the actual integration a to b f of x from alpha dx. Now, to do such integration, we use two rules. First rule is used if a and b are constant. Which is di by d alpha is equal to integration a to b partial derivative with respect to alpha of f of x comma alpha dx. Which is di by d alpha is equal to integration a to b delta by delta alpha of f of x comma alpha close the bracket dx. Okay. Now you write down. However, if A and B also depends on alpha. That is I alpha is integration A alpha to B alpha f of x comma alpha dx. I alpha is equal to integration A alpha to B alpha f of x comma alpha dx f of x comma alpha dx. Then we use dy as root 2. Then we use dy as root 2, which is di by d alpha is equal to integration a alpha to b alpha gamma by gamma alpha of f of x comma alpha close the bracket. First, I'm going to differentiate whatever is the answer. I'm going to integrate. Is this okay? A alpha to b alpha gamma by gamma alpha of f of x comma alpha. Whatever is the answer after differentiation, then integrate it with respect to x. Plus, what do we do with upper limit? We do it plus one. Upper limit is added. So whose upper limit is this? This is the upper limit of x because integration is with respect to x. So b alpha is the upper limit of x. So replace x by b comma alpha and differentiate b with respect to alpha. Is this okay? What I have done? How can I go to write down the component which will come because of b alpha? It will be replace this x by upper limit and differentiate the upper limit with respect to alpha. If this you have understood, tell me what will be the lower limit? What will be the contribution into lower limit?
minus f
Very
of
good.
f of a alpha
Very good.
d
Into
a by d alpha.
A by D alpha.
very good. That's the answer. Is this clear? Very simple. Here a and b were constant, so they will contribute to differentiation of a and b with respect to alpha, and they were constant. Derivative of constant with respect to any variable will be 0. But here in the limits a and b are depending on alpha, so they will contribute to the final differentiation. And how they contribute? X should be replaced by upper limit and differentiate the upper limit minus x should be differentiated with respect to lower limit and replace x by b. A. Is it okay? Is that clear?
Yes, ma'am.
Yes,
Now,
ma'am.
anybody wants to relate the two? dy is rule 1 and rule 2. If you have understood this two, tell me what is the relation between rule 1 and rule 2. It's very straightforward. Right, think, take 2 minutes and think. Quickly.
रूल ए मध्ये ए आणि बी कॉन्स्टंट ना म्हणजे फर्स्ट रूल मध्ये
Yes, so what will happen?
dv by
So
dy
if
Specific
A is
condition
equal to
of
f of
b.
x and b is equal to g of x, then this is going to
No. What?
instead of the limits of a and b which are constant, if we replace it by the functions which are dependable on y on alpha, then the terms f of b comma alpha db by d alpha minus f of a comma alpha d alpha
They exist.
will get added.
They
Yeah.
exist. They exist. So that's what I'm saying. When I'm asking you the relation between the two, that is, I'm trying to ask you, who implies who? Who is stronger?
Who is?
Stronger. Which rule is stronger? Who will
Second
give the
one.
other rule?
Two, no?
Rule two is
Two,
second
because
one.
it is general.
Second
thing.
one.
Absolutely. So actually, rule 1 was found first. That's why it is given. It is directly possible to get rule 1 from rule 2. How?
There is specific
Because
condition, ma'am. Alpha is equal to 1.
Yes.
Specialized condition, yeah.
Yes, that's right. dv by d alpha, since b is constant, derivative of constant with respect to alpha will be 0. So this term is not there. A is constant, therefore derivative of a with respect to alpha also will be 0. So this term will automatically, this term will go away. Only this term will remain. But however, this was found first, that's why it is 0. Are you getting it? So there is actually no need for writing rule 1 separately. It is a special case of rule 2. Rule 1 is special case of rule 2. You can say current rule of rule 2. That's why rule 2 is more powerful. Is this clear?
Yes, ma'am.
Everyone?
Ma'am, can you take one example and explain?
Yes, definitely I'll take, but rather than taking the example, this equation, this whatever I'm writing, that clear to everyone? If the limits are having alpha in its what do you say, in the limits, then if I'm differentiating this after integration, I will get upper limit, lower limit. Those contributions should be counted, and hence how do we calculate? Upper limit is always positive, lower limit is negative. So upper limit will be having differentiation of upper limit with respect to alpha will be there, and x should be replaced by upper limit, and minus lower limit will be negative, so d with respect to alpha and replace x by d. If you get this, then all the examples are very simple. I'll explain it. That's not at all a problem. But are the rules why they are and how they are related to each other clear to everyone? Yes, Neeraj?
What, ma'am?
Why these rules are there, what's the use of it, and how you are going to use it, that is the later case. But how rule 1 is special case of rule 2.
Yeah, I understood that, yes.
Okay. Now let's go to the example. So let us get down. We'll start with the simple example and then we'll go to the complicated. Okay. So take down. Evaluate integration. Evaluate integration zero to infinity. I'm writing integration 0 to infinity e raised to x minus e raised to minus ax upon x sec x dx. Evaluate integration 0 to infinity e raised to minus x minus e raised to minus ax upon x sec x dx with a greater than 0, and this is phi of t. This is phi of t. So all that we are doing in unit number 3 are special integration calculus, integral calculus. So these are all the integration that we have not done till now, and we are trying to find out various methods of solving those type of integrations. So whatever you have studied in your high schools, are you able to solve this integration, which is such a lengthy one? Or even if you try to take it as a product of two functions, e raised to x minus e raised to minus x will be one function, 1 upon x sec x will be second function, by parts that if you want to try, it becomes so complicated, isn't it? Yes or no? Quickly.
Yes, ma'am.
Okay. So therefore, this integration, it is having the integration with respect to x, and final answer has been in terms of a. That means a here is appearing as a parameter and x is the integration variable. Is it okay? And that's why we can think about dys. Here?
Yes, ma'am.
Yes, ma'am.
And that's why I'll first what I do, I go for dys2 as we have a to be parameter. Please write simultaneously, parameter, and x to be integration variable as well. I'm writing this for your understanding as well. Integration is difficult. We use dys. Okay. Now which rule do we use? Rule 1 or rule 2? Even if you use rule 2, not a problem. Directly you get an answer. But clearly, what are the limits? Are they depending on a?
No, ma'am.
Limits are constant. Limits are constant. So I'm writing it. Even if you don't write and use rule. What is that? d phi by dA. Who is your parameter now? A. So d phi by dA is equal to integration 0 to infinity delta by delta A of e raised to x minus e raised to minus ax upon x sec x into for differentiation and then to the integration. Obviously, the second term and third term is easy because derivative of infinity with respect to a is 0, derivative of 0 with respect to infinity is also with respect to a is also 0. what I will write down those and take plus 0 minus 0. Is this okay? Why is plus 0 minus 0 if I use rule 2? Huh? Since I have written the rule 1, don't write this. Okay? Clear? Yeah. Now be careful while doing the differentiation. So listen. Don't write anything, please listen. So what is d phi by dA? d phi by dA is integration is revealing outside derivatives. I have to differentiate with respect to A. So who will be constant? Partial differentiation. So who will be constant? X will be constant. X sec x is in the denominator in multiplication. So it will remain as it is x sec x. It is appearing as a constant. Can you see that?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Now in the numerator we have two functions which are in addition or subtraction. What's the derivative of e raised to x with respect to a? X is constant.
0.
What's the derivative? Very good. 0. Minus e raised to minus ax derivative with respect to a.
Minus x
Minus e raised to minus ax into
minus x.
derivative of the power with respect to a. So a is your variable, derivative of a with respect to a is 1, x is a constant, so x will come. Are you getting it?
Yes, ma'am.
This is the only step we have to be very careful. Now, how do you, those who feel that this is quite complicated, what should happen? The term which is making problem, this x which is making problem, that should go. So it should appear in the multiplication in numerator, so that x cancel. That way you can try to relate it. Otherwise, if you are able to apply the rule correctly, this automatically x will come. Otherwise, many students they do the mistake of general habit of having differentiation with respect to x. They write a, and then it becomes still complicated. Are you getting it? So always keep in mind when you are applying DYS, I want to make the integration simple. So the term which is making problems should get cancelled. So which is the term which is there in the denominator 1 by x derivative or integration will never get it. So that should do. And that's why if x comes in the numerator, therefore it will get cancelled. And hence this x and x cancels. I will get 0 to infinity minus of minus will become plus. And it is e raised to minus ax upon sec x. Dx, which is nothing but d phi by dA is equal to integration 0 to infinity e raised to minus ax into cos x. Whose integration formula we have written? What is the formula? D phi by dA is equal to e raised to minus ax into minus a cos of x plus b is 1 into sin x divided by a square plus b square. What formula I have used? I write it here. The formula that I have used is integration. I have to write down the integration. Integration e raised to
ax cos bx.
X dx is nothing but e raised to ax a cos bx plus b sin bx divided by a square plus b square. This is the formula which we have written. And this was proved also by one of the students in my semester. E raised to ax into a cos bx plus b sin bx upon a square plus b square. B is 1 over here now, and a is minus a. So minus a cos of 1x plus 1 sin of x upon x square plus 1 square is to minus 6. Clear? Everyone?
Yes, ma'am.
Everyone? Remaining students also?
Yes.
Yes, ma'am. Yes.
Okay. So now you put the limits. Upper limit and lower limit, you please put, then tell me the answer. After you put the limits. When you put upper limit as infinity, e raised to minus infinity is 0. Correct? E raised to minus infinity is 0. Minus lower limit. E raised to 0 is 1. Minus a cos of 0 is 1. Sin of 0 is 0. Divided by a square plus 1. So what is your d phi by dA here? I'll write this up. Okay. Therefore, d phi by dA is nothing but a upon a square plus 1. Okay. Now, is this integration, this differential equation known to you? Do you know how to solve this? This is the differential equation associated with the given integration.
1
So
by
we-
2 log a square plus 1.
Absolutely right. This is variable separable. Variable separable differential equation d phi is equal to a upon a square plus 1 dA. Derivative of a square is 2a. So adjust that and do the integration. Therefore, phi of a is equal to 1 by 2 log of a square plus 1. Now, note this is not definite integration. That's why plus c will come. You have to find the value of c. You have to find the value of c. So how will you find the value of c?
A
Always
is greater than
alternate.
0.
Yes. So a is greater than 0. I have to select some value of a, which will help me to get the value of c easily. Okay. So I'll take a to be equal to 1. So take, let me just take, should I have this? Take a equal to 1. If I take a is equal to 1 from this equation, I'll call this as 2. I'll call this equation as 1. Given question is 1. So from 2, what is it? Put a is equal to 1. Phi of 1 is equal to half log of 1 square plus 1 plus c. What is that equal to? Phi of 1 is equal to half log 2 plus c. Okay? Still I have not got the value of c. How will I get phi of 1?
And put the
From
First
1.
equation.
Yes, very good. From the first equation, put a is equal to 1. You get phi of 1 is equal to integration 0 to infinity e raised to minus x minus e raised to a is 1 minus x upon x seconds. So numerator is 0 and therefore the integration is 0. So what is phi of 1 from? Given the question, phi of 1 is 0.
then it is e raised to x, no?
Ma'am, it's
E raised to x minus e raised to minus x.
minus e raised to x, yeah. E raised to x, ma'am, पहला term numerator में.
Let me check it. I think so. I have made a mistake. Yes. This is minus. It won't become so complicated. If this was minus, if this was plus, if this was a still, I have to again do the integration of this one, which is not
Yeah,
going to solve
right.
that here. So it is minus in the question has minus, I have still. Okay? Clear?
Yes. Yes.
मॅम
So
मग
far,
d phi by
yeah.
dh ची व्हॅल्यू चेंज होईल ना?
बरोबर. त्याच्यामध्ये a नाहीच आहे. मग कशाला त्याच्या डिफरन्शिएशन मध्ये बदल करेल? इथे a आहे का?
मायनस साईन चेंज होईल.
ज्याच्यामध्ये a असेल तर डेरिव्हेटिव्ह मध्ये चेंज झाला असता ना. दिस इज हॅविंग ओनली x. So x is constant. Constant चा डेरिव्हेटिव्ह 0.
Yeah,
प्लस
same
असू दे किंवा मायनस असू दे.
ओके.
कळालं का नाही?
येस येस.
डिफरन्शिएशन आपण a बरोबर करतो. x बरोबर नाही. x बरोबर केलं असतं तर फरक झाला असता. पण आता आपण डिफरन्शिएशन a बरोबर करतो. So it won't make any effect because the differentiation is with respect to a and here it is x plus x or minus x. That would have changed. But differentiation is with respect to a. So no effect. Derivative will be 0 only.
ओके.
Okay? Yeah. So phi of 1 is 0 and therefore your 3 becomes 3 gives you 0 is equal to half log 2 plus c, that c is equal to minus half log 2. For this is put into that the formula. Put in equation 2, therefore phi of a, which was the integration asked, is half log of a square plus 1 minus half log of 2, half log of 2, which is half log of a square plus 1 by that's the formula. Phi of a, this integration is equal to this half log of a square plus 1 by 2, which would have never or by any of the standard method that we have done till now. Is this okay?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, please complete this quickly so that I can give you one more question and you try to solve it, okay, on your own totally. So what we have done differentiation first because the integration was difficult to solve directly. Then we got a differential equation. That differential equation we solved by your unit 1 help, that is differential equation of variable separable, and we got a relation which has arbitrary constant c. always arbitrary constant C is found with the help of initial condition. The initial condition depends on condition given on A. A should be greater than 0. So you can take any value of A greater than 0. I put it to be 1. So that my integration which is given to you, question becomes simple. And that's why that turns out to be phi of 1 is equal to 0. From equation 2, I get right hand side value, which gives me the value of C to be minus half log 2. Back substitute that value of log C in terms of phi of A, which we got by solving the differential equation. That is the final solution of your given integration. Is that clear to everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. Fine. So let me give you another question to try to solve this. I'm giving you the entire question, okay? Because in your MCQ, how will be asked? What will be asked? What is the differential equation associated? Given the differential equation, what is the final answer? 2 marks question. Is it okay? Everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
So immediately try to solve this question, which I'm giving you next. Integration 0 to infinity, e raised to minus x, upon x, e raised to minus x upon x, into 1 minus e raised to minus ax dx for a greater than minus 1. A greater than minus 1. Right? And get me the answer. One more question I'll give you. Here there is only one parameter. It can have more than one parameter also. So that kind of question also I'll give you. And then we'll go to today I want to complete COS. Integration. Zero to 1. X raised to b minus x raised to x. X raised to b minus x raised to b upon log x dx is equal to log of a plus 1 upon b plus 1. A plus 1 upon b plus 1. Where a is greater than 0, b. Some of you saw the second one, some of you have saw the first one. Give me the answer.
Ma'am,
Yeah,
first one का है phi of a equal to log of a plus 1.
I think so. That's the answer. Correct. Let me cross check it. Okay. Yes, log of a plus 1 is the answer.
Yes, ma'am. Log of a plus
Yes,
1.
ma'am. Yes.
Okay, everybody is getting it? If anybody is not getting, please tell me quickly. Those who have solved the first one, answer is correct. It is log of a plus 1. Solve the second one. Those who have not got, please see here what I'm doing. Okay. Again, the integration is not so simple because we have 3 functions. We don't know how to go for bypass for 3 functions, or even if we treat them as 2 functions, it's going to become difficult. So let me first differentiate it. There is only one variable x with respect to which I have to integrate, and a parameter a, which is giving me the final answer. So I'm differentiating phi with respect to a. Limits are constant. That's why we have to take first rule 0 to infinity partial derivative with respect to a of e raised to minus x upon x into 1 minus e raised to minus x. This differentiation into x. So that differentiation will become, what will be that differentiation? It will become d5 by dk is equal to integration 0 to infinity. When I am differentiating with respect to a, who will be constant? X will be constant. So x is constant, e raised to minus x upon x will remain as it is. Derivative of 1 will be 0 minus derivative of e raised to minus x is minus e raised to minus ax into x. Correct. So this x and x gets cancelled. This is integration 0 to infinity minus of minus plus e raised to minus x into e raised to minus ax. It's very simple integration. So it is 0 to infinity e raised to minus x into a plus 1. So this integration is nothing but e raised to minus x. Now here integration is with respect to x. So what will come in the denominator? A term will come in the denominator. Please, this is very careful. The way you have to do differentiation carefully, integration also should be done carefully. Plus c, sorry, there is no need to write plus c because there is definite integration. So 0 to infinity. E raised to minus infinity 0 upper limit. Lower limit is e raised to 0 is 1.
Minus either.
Yes,
Minus of 8.
there will be minus sign because, yeah, derivative of minus x into a plus 1 is minus a plus 1, so there will be minus sign. Upper limit e raised to minus infinity is 0. Lower limit minus of minus will become plus, and it is 1 upon a plus 1. So d5 by dk is equal to 1 upon a plus 1. This is differential equation which is variable separable, and therefore d5 is equal to dA upon a plus 1 integration plus constant of integration c. Therefore phi of a is equal to log of a plus 1 plus c. Finding the value of c, I have to put a to some initial condition. What's the condition on a? A is greater than minus 1. So can I take a to be 0? Why am I taking a to be 0? Because e raised to 0 will be 1, 1 minus 1 will become 0. Therefore, phi of 0 is equal from 2. Phi of 0 is equal to log of 1 plus c, but log of 1 is 0. So this is c, phi of 0. By definition of phi of 0, integration 0 to infinity e raised to minus x upon x into 1 minus 1 dx is equal to 0. Therefore, c is 0. And hence your answer of given question phi of a third will become just log of a plus 1. So that is, this is equal to log of x. Okay, fine. Clear everyone?
Yes, ma'am.
Yes, ma'am.
Anybody has any doubt? Please ask. If it is clear, what about the second one? Second question. How many variables are? What are variables? What are parameters? You have to tell me that.
Ma'am, can we
variable are there.
solve
We can
with
separate
phi
them
of
that.
A and then phi of B?
You can solve, and then you can subtract them. It will become log of. That is also
Yeah.
but you do it together. It will be more simple. You can
Phi
take
of A
any
comma
one.
B?
Or no, take one variable because then how you are going to differentiate.
Phi of A.
Start with phi of A or some of them start with phi of B. You get the answer of that has to be log of minus log of that b plus 1, and then c it around b plus log a plus 1, and then you get the answer. So anyone will start, you will get the same answer. So let me. What do you want me to start with, phi of A or B?
A.
So phi of A, if I take x to be 0 to 1, x raised to a minus x raised to b. Because the differentiation is with respect to one variable, so I cannot take both terms. So what will happen otherwise? This side also partial derivative, that side also partial derivative. That is not given by this. There is some other techniques to do those type of things together. So right now we are going to take one of them to be parameter, other item will take it to be constant. So phi of A is equal to integration 0 to 1, x raised to a minus x raised to b log x dx. This if I take, then d phi by dk is equal to integration 0 to 1 partial derivative with respect to a of x raised to a minus x raised to b upon log x. Whatever is your answer, dx. And therefore, d phi by dA, therefore, d phi by dA is becoming equal to integration 0 to 1 derivative with respect to A. So what is the derivative done? Log x will be as it is constant. Derivative of x raised to A with respect to A. What it is?
1.
Cool.
A x raised to a minus 1.
X raised to a
X raised to a log a. Raised to a log a.
to a into X log raised a.
Yes.
Yeah, x raised to a into log x.
I told you the hint. Who is making the problem to solve this integration? Log x.
Log
So
x.
log x should go. So multiplication में log x आना चाहिए. समझ में आ रहा है? What's the hint?
Yes,
X
ma'am.
raised to a.
Yes.
Here you go wrong because you generally have the habit of differentiating this with respect to x, and then you say the answer of this derivative is a x raised to a minus 1. But I'm not differentiating with respect to x. I'm differentiating with respect to a. So this is of the type constant raised to variable. This is of the type a raised to x actually. Or you can write some new variable. This is of the type b raised to x. So what's the derivative of b raised to x? Generally,
B raised to x into log b.
Into log x.
So you are what will be the derivative of x raised to a? Let me write it down here. What it is?
X raised to a log.
X raised to a log of x. Log x again. How log a? A is the variable. X is the constant. So log x. Okay. What I used? I use the derivative of a raised to x as a raised to x log of a. Now since you are getting confused, let me write it as b raised to x or c raised to x. So it is c raised to x log of c. So replace c by x and replace x by a. You get that answer. And what is the derivative of x raised to b?
0.
0.
Everyone is understanding that it is 0 because x is also constant and b is also
B is
constant.
also constant.
Yes. So it is 0 and that's how this much will be there. So log x cancels and you get the answer is to be x. Now we are doing the integration with respect to x. So it is x raised to a plus 1 upon a plus
Upon
1
a.
from 0 to 1. Is it okay?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And that is d phi by dA. So d phi by dA becomes equal to put the value of
1
x.
upon a plus 1.
So 1 upon a plus 1. When x is 0, lower limit will become 0. Now separate this as variables as given. D phi is equal to dA upon a plus 1. Integration plus c. So phi of a is equal to log of a plus
A
1
plus 1.
plus c. So what do you think you will get c value? So that we get
Minus log of
no.
1 plus
Look
1
at the
plus
answer. You should be smart enough. You want the answer to be log of a plus 1 upon b plus 1. So value of c won't be 0. It will be minus log of b plus 1. So that directly get the answer. समझ में आ रहा है?
Yes, ma'am.
Yes, ma'am.
So for that b should come into picture.
Ma'am,
So what do you do?
Take a is equals to 1.
If you take a is equal to 1, this will become x raised to 1 minus x raised to b.
Ma'am, A is equal to B.
Absolutely right. Take a is equal to b because what we said in the beginning, you can start with anyone, so they can be replaced by each other. So take a is equal to b, therefore you get phi of b is equal to log of b plus 1 plus c. But what is phi of b by definition of question? Phi of b is nothing but integration 0 to 1 x raised to b minus x raised to b upon log x dx, which is nothing but 0 because x raised to b cancels. And therefore your equation 2 becomes phi of b is 0, left hand side is 0, is equal to log of b plus 1 plus c. And therefore c is equal to minus log of b plus 1. Substitute this value into, put c into, you get phi of, or in one, sorry, I'll call this as 3, I'll call this as 2. Okay. So from 2, if you put the value of c into, you get phi of a is equal to log of a plus 1 minus log of b plus 1, and that gives you the answer as log of a plus 1 upon b plus 1, which is expected answer. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So that is the way this differentiation and the integral sign. And you should know this because you are going to require this in your M3 also. So again, your teachers ask them, so how you are going to do this integration? This you got this integral after trying to solve the Fourier transform. Then you should try to remember whatever we have done in 12th standard to integration किए थे both apply नहीं हो रहे. तो फिर whatever we did in M2 integral calculus, beta function, gamma function, reduction function, dys, is it applicable? If I want to apply dys, then what should happen? There should be a variable and a parameter. So alpha will be there as a parameter and x will be your integration variable. So you should say immediately we use dys. Okay? Here? Yes or no?
Yes, ma'am.
Okay, fine.
Yes, ma'am.
So we'll do now one question. There are still 10 minutes left. One or two questions we'll do and then we'll stop. So have you completed this entire question? Good. So again, I'm taking the general question. They will be distributed in parts. The first part, that is what is phi of A, that can be asked for 2 marks. Then 25 by A, what is the final relation between this integration and log, that may be asked. Okay. So let us go to now questions wherein the limits are having the parameter. So take down question itself directly. If f of t is equal to integration t to t square e raised to tx square dx, e raised to tx square dx, then find df by dt. Where the integration is easy actually, there's nothing difficult in it. But they have asked you in the question only find df by dt. So you have to use dys too. Is it okay? So how will you go about it?
And the second tool.
Ma'am, 2t e raised to t raised to phi.
Final answer you're telling me df by
Yeah.
dt.
Yes.
What it is? Tell me the answer.
2t into e raised to t raised to phi minus e raised to t cube.
And what about the first integration? You forgot that. You told me only the upper limit part and lower limit part. What about the actual integration? Yeah, there's a differentiation that you have to skip.
Okay, okay.
You are right. Second and third part is right. Yes, rule 2 is applicable. Why? Because I have to do the integration with respect to x and the limits are in terms of t. So t is your parameter. So we have said differentiate with respect to t means t is your parameter. Therefore, by DUIS rule 2, what we have df by dt is nothing but integration t to t square delta by delta t of e raised to tx square dx plus in case of x to the upper limit, that is e raised to t into t square raised to 2 into derivative of the upper limit, that is d by dt of t square minus in case of x to the lower limit, that is e raised to t into t square and derivative of the lower limit. Is this okay? So that is equal to integration t to t square. What is the derivative of this term with respect to t? X is constant. So it is
X square
x square e raised to
t square.
This is the constant, it will come down. I'm doing differentiation, not integration, so it won't be down. This option is also there in the ABCD, okay? This x square will be divided, but I'm doing differentiation. So whenever we are doing differentiation, derivative is multiplied. Whenever we do integration, derivative is divided. So here, x square into e raised to tx square dx plus t square derivative is 2t e raised to total how many? 2 raised to 4 plus 1 5. So t raised to 5 minus square plus 1 3. So t cube
Take.
and derivative of t with respect to t is 1. So minus t is to t. That's why in f by. This is the question for 2 marks. Yes. Is it okay? Everyone?
Yes.
Okay.
Ma'am, can we solve it for the integral?
That integration, if you want to solve it, x square, yes, you can solve it. Put x square is equal to variable. You can solve it. Limits will change.
Okay, I'll try.
But right now, the expected thing is only application of rule. We can also solve this by one. No, but the limits there are 0 to 1. Na? Gamma function, do you see? Gamma function. Can you see gamma function in this?
Yes.
But then limit should be 0 to 1.
Then we'll use the substitution property.
Substitution you get the answer.
Yeah.
Put x square is equal to u, then, but again root will come. Na? So u into dx will become 2x dx. So 1 dx, even if you take that, x will become a root of. And then the limits will change. So it will not be so easy. Because the limits are k to t square. Are you getting it? We'll try.
Yes, yes. Yeah.
So should I give you one more question of this type that will actually make you more comfortable and confident about whether you can apply the rule carefully? Take down. And then we'll stop. If f of x is equal to, integration a to x, f of x is equal to integration a to x, x minus t square into g of t, g of t, then find the third derivative of f of x with respect to obviously x. That is df cube by dx cube. Actually, they have given the answers in the option as to be the differential equation. df cube by dx cube plus or minus something is equal to 0. That is what they have given. But I have reframed the question so that you won't directly see the answer and then try to get it. Try to find out what will be the relation between the third derivative and the given question. So how many times you have to apply the rule? If I want df cube by dx cube, how many times I have to apply the rule?
3 times.
3 times. Okay, I don't want to take too much part from your break. So let me start quickly and show you how it will apply. So let me go for the first time. df by dx is equal to integration a to x mega x of x minus t the whole square into g of t, then dt plus upper limit. Where is the upper limit? Whose upper limit it is? Variable is t. Integration variable is t. So in place of t, you have to put the upper limit. So it is x minus x square into g of x. Okay, into derivative of x with respect to x. So don't write anything lightly. This is 0. This is the first time I'm doing, so I'm telling you. When you practice more, there is no need to write also this. Minus lower limit. What the lower limit? A. A is a fixed constant. Huh? So x minus a the whole square, g of a into derivative of a with respect to x. So that is also 0 because derivative of any constant with respect to any variable is 0. So what remains? df by dx is only integration a to x. What's the derivative of this term with respect to x? 2 into x minus t, g of t is constant dt. Is this clear? Everyone, please
Yes,
reply.
ma'am.
Okay? I'm stretching, but please say yes. We have time constraints. So that's the first derivative. What will be d to f by dt square dx square? Please try to see. D to f by dx square. What will it be? One more time integration. Inside that differentiation of 2 into x minus t g of t, and then whatever is your answer dt. Do you want me to write down the second and third term? In place of t, I have to put the upper limit. So x minus x term will be
0.
0. So
Zero.
plus 0. And when you put the lower limit, x minus a will be there. But derivative of a constant with respect to x is 0. So
Zero.
that term also. So what will this become? Integration a to x, derivative with respect to x is 2. X minus t derivative with respect to x is 1 minus 0, which is 1. Into g of t. But I want to find the third derivative. So d cube f by dx cube is nothing but integration a to x, derivative with respect to x of 2g derivative 2gt into dt. But now the upper limit and lower limit won't be 0 because there is no x minus t term. So put the upper limit in place of t as x. So 2gx into dx by dx. Lower limit will be 0 because derivative of constant is 0. Derivative of this term with respect to x, there is no x. So derivative will be 0. And integration of 0 is 0. Therefore only you get 2gx. Because dx by dx is 1. And therefore what's your relation? Your relation is nothing but d cube f by dx cube minus 2gx is equal to 0. That will answer. The differential equation which is satisfied by f of x given by this integration is d cube f by dx cube minus 2gx is equal to 0. So now what is the use of this? This integration will come across when you are trying to solve Laplace transform, but it is not going to be easy to solve. Is it okay? Because the t is also x is also a variable or parameter and this. So I am able to do that. And you are not given the relation also between x and t. So you will convert this to the differential equation associated. So this is what differential equation? It is the differential equation of order 3.
3.
So we have not seen how we solve a differential equation of order 3. So in M3, the first unit which is there is differential equation, ordinary differential equation of higher order. So there we are going to see how we solve this, and that will help you to get what is the actual answer of the problems. And that's why you should know what the three ones. Is it okay? Clear?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes.
So we'll stop here. You please try to solve the MCQs which are there in this part of your tutorial 2. And if you find any doubt, you please ask me tomorrow itself. Because tomorrow I'm going to start with error function. So go through the MCQs today itself.